Hi, okay, welcome. Here we are again. We're at session 5, I believe. We're doing really well. We've got our normal recap. I want you to solve and sketch the first sort of 3 squares. Let's just highlight the ones: solve and sketch, solve and sketch, solve and sketch. And these ones are obviously completely different. These ones you will be expanding. If you need to look anything up, then please do. And I will see you in a minute when you press play to look at the answers. Okay, so these are your answers. Let's get that down a little bit. There we go. And you can see that I haven't done the ones that are highlighted. I thought that there was a chance that they may cause a little problem. So I thought I'd just go through those. So mark the ones that you've done. You can see that the quadratic formula was used for those first 2. And hopefully your expansion went well. I was pretty mean, wasn't I, sticking a -5 here. Okay, so hopefully you stayed on top of all that negative work. All right, let's look at these 2 questions, okay? And what I'm going to do is I'm just going to rub out this side so I've got some space. 3x squared plus 4x equals 0 is most definitely a quadratic. Okay, it's assumed knowledge. This is your sort of grade 4 even, grade 5 maximum kind of quadratic. But because we haven't seen it for a little while, it's very easy for us to just be in a zone rather than be just thinking, what am I looking at? What do I know? Okay. We don't want to be robots trying to recognize a question so we can answer it. We want to be able to apply our knowledge of a topic. So when I'm looking at this question, I'm going, okay, I'm looking at a quadratic. Great. It equals 0. Perfect. That means I'm at a stage where I can use a method. I'm going to look at factorizing this. I've got 2 terms, which means I've got 1 bracket. That's the general rule, okay? If I look at the numbers, I don't have anything that's common, so nothing is coming out onto the outside of the bracket. But x is common, so x can. So x will come out, and I will then have 3x here to make 3x squared when it's expanded, and just 4. So again, when it's expanded, x times 4 is 4x. So that's my factorized version. And remember, it's all about making the bracket, so that's what we've learned so far, to equal 0. This here, we should be able to do fairly confidently now. That's going to be x equals minus 4/3. But this here may have caused a little issue. I hope it didn't, but it may. That x is squashed to the bracket, so it's x times the bracket. If that x equals 0, then it doesn't matter what's going in the bracket. So that x has to equal 0 automatically. So if you get a single x coming out, then it will equal 0. Okay, so just to make sure you've understood that, if that x there is 0, it can times to this, doesn't matter what it is, it will equal 0. And then obviously if this is 0, it can times to that, doesn't matter what it is, because it will equal 0. So we're following that same understanding when we've got 2 brackets, we're just doing it where we've got 1. So to sketch that, we would just use those crossing points to help us get them in the right place. And of course, there is no y value, is there? So let's just get my grid in. Okay. It's crossing at -4/3. Let's just say that's there. And at 0. It's already crossing the y-axis here. So it's not going to try and go in the positive or the negative. There is no additional value here on the end, making it a 3-term quadratic, is there? Okay, and that is because one of the solutions is 0 and it's already crossing through. So it would look obviously something like that. Okay. Now, the other one's really important and has been included because it happens to be the exception to the rule. Okay, so if I've got x squared minus 49 equals 0, I'm going to say to myself, 2 terms. that'll be one bracket then. And I get my bracket, and then I start looking to see what would live here. So I've got an X, but I don't have an X over here. So there's not a common X that can come out. And there's no number here. So there isn't a common number that can come out. So me trying to go into a single bracket just isn't working. It's an epic fail. So this is the exception to the rule, where in fact there is going to be 2 brackets. Okay, so our rule is when there's 3 terms, let's look at over here, and there's 1, 2, 3 terms. If it would factorize, there'll be 2 brackets. If there's 2 terms, there is 1 bracket. And that is true for 90 plus, 99%. That's true of absolutely the vast majority. But then there's this one itty bitty little condition that just pops in that's different. This here, let's highlight it. This here is a special number. It's negative, which is important, but we'll explain why that's important in a moment. The number itself is 49. It's a very special number. It's a square number, which means I can square root the 49 and I can get the result 7. Now, when I think about making that 49, 7 times 7 is 49. And if I square root 49, it's 7. That's what I understand about my squaring and my square rooting. But look at this. Minus 7 times minus 7 will also equal 49. So how do you know the answer isn't minus 7? If you're square rooting a number, whoops, let's say 49 again, the better answer to give, the more precise and accurate answer to give is plus or minus 7, because it could have come from either one of those calculations. Unless there's some context to the story, like it's an area question or something, where you could never get a negative value, then you would put plus and minus the result. Okay, so what effect that all has on my factorizing is I drop the X, I do the square root of 49, which is 7. It could be plus 7, it could be minus 7. Okay, so that is the answer. That is the answer. Now let's just crab's claw that out, just to show you why there's only 2 terms. X times X is X squared. X times minus 7 is minus 7X. X times 7 is plus 7X, and X times, 7 times minus 7 is minus 49. And if you look now, you can see that minus 7, add 7, cancels each other out. It disappears, leaving me just X squared minus 49. And you'll always get this minus situation because you've got that minus and a positive, that minus and a positive, making it there. And then that minus and that positive cancels out the middle, and you end up with just 2 terms that should really be going into 2 brackets. So to identify that, you would be looking for the square number, basically. This only happens when you get a square number, which is why there's such a tiny number of quadratics that this impacts, and the vast majority use the general rule that we have. And the graph for this, just to completely finish the whole thing off, okay, is going to be, let me get my colors. I'm going to try and do us a groovy arch. It's going to be, that's pretty good. So what we're saying is it's crossing at positive 7, negative 7, and this would be minus 49. You would expect it to loop down a lot lower, wouldn't you? Okay. Right. That is our recap, with plenty of explanation on those extras, because they're going to pop in. We need to be really confident that it doesn't matter what quadratic is thrown at us, we are able to deal with it using all of our knowledge when it comes to quadratics. Okay, on to the next thing. So today we are going to be forming and solving simultaneous equations. And you can see I've highlighted the forming and solving. Normally, we are just given a simultaneous equation and we just crack on with our method. That's grade 5. So for this course, that's assumed knowledge. You should be able to look at that and be able to do it. Okay, what we're doing is we're moving on to forming our own equations, so actually writing them ourselves. Now, I don't want to completely bypass the method, just in case you haven't done it in a little while. If you are a little bit out of practice and you need to do some of this, then I would strongly recommend that you use this example and then you go away and you do some practice, okay? And then you come back and look at the next step. So let's talk you through this with a little bit of detail, just in case it's been a while. So the first thing that I need to do is I need to make sure that the first term, and this could be any letter, it's not about necessarily the X, it could be any letter, but I need to make sure these are the same. And at the moment, they really are not. So in order to get these the same, I'm going to cross multiply. So I'm going to multiply the top one by 3 and the bottom one by 2. And then I will rewrite my equations. So I've got 2 times 3, that's going to be 6x minus 9y equaling minus 24. Really important that I multiply every single term in my simultaneous equation so that I can keep everything equivalent. If I only do it to 1, then I've changed the question. Okay, the bottom one is going to give me the 6x, and then we've got plus 10y equaling 90. So that sorts out my initial problem where the first variable, or the first term, I should say, isn't matching. So I'm going to do a takeaway. So step 2 is to take away the x's, take away the y's, take away the numbers. Really important to show that because there's a lot of signs and we don't want to get ourselves confused. So I'm going to circle this because I've put in a minus and there's already a sign here. So I want to pop them together. There's no sign to circle, so I'm not circling here. And there's no sign down here to circle, so I'm not circling here. It's all about the under sign, not the over sign, okay? So I am going to be doing 6x, take 6x. That means I don't have any, they've gone. So it's eliminated, it's done what I want it to do. The x's have gone, I can just concentrate on my y's. This says I'm at minus 9. You can see the minus sign here, minus 9. So I'm at minus 9. A plus and a minus makes a minus. So I'm going to take away 10, and that's going to take me all the way to minus 19y. So that is why I do the ringing, okay? Because if that had been negative, 2 negatives would have made a positive. I would have done a completely different piece of maths there. So that ringing really helps me identify what I'm doing and hopefully reduce the errors. Here I'm saying I'm at minus 24. I'm going to take away another 90. That is going to take me to minus 114. Okay, as I say, that bit there is where it can often go wrong. So show those signs, do the ringing, and do everything that you can to help yourself not make an error. Because once it's gone at that stage, it's going to throw everything out. Okay, I want to know what y equals, so I'm going to get it on its own. I'm going to divide that through by minus 19 to find that y is equal to 6. Now I have a value for y. I can use it in either of the 2 original equations. Basically, I've got an option to use this one or use this one to help me find out my x value. Now, I'm actually going to choose the bottom one, all right, simply because there's a few negatives in the top one. I'm not looking for work. If negatives are my thing, I'm going to try and avoid them. So I'm going to choose that one for that reason. So I've got the equation 3x plus 5y equals 45. I know from this working out that I've just done that the y is going to equal 6. So 6 will go where the y is. Now I'm going to rewrite that. 3x plus 5 times y. 5 times 6 is 30, equaling 45. And then I want to get x on its own. So I'm going to take off the 30. divide through by that 3, and x is equal to 5. So y is equal to 6, x is equal to 5. Those are your standard simultaneous equations and the method that you would use to solve them. Okay, we, however, are forming. So it's reading through a worded problem and pulling those equations out ourselves. It's not easy. I'm not going to try and pretend that it is. Some questions are easier to spot and see than others. I've tried to do 3 examples that give a little bit of variety, so you get an idea of how they could possibly do this in an exam. And then obviously we've got our practice questions. This is something that will take time, all right? It's quite a new thing, I would imagine. How common is it in the exam? It's getting more common, let's put it that way. Recent papers are starting to put this in a little bit more. So we definitely want to be aware of it. We don't want to rely basically on them literally giving us a simultaneous equation question and boom, we go on and solve it. They are starting to make them tougher. So we want to start just developing that skill to be able to do it. So let's look at this first one. I've got 2 numbers. So let's say those numbers are x and y. They could be A and B, they could be E and F, they could be whatever I want them to be, okay? But I've got 2 numbers and I'm going to call them x and y because I don't know what they are. They have a sum of 53. So that tells me that the x, whoops, let's get the pen back, the x and the y will add together to make 53. And they have a difference of 11. So I know that the x take the y would equal 11. I've got my simultaneous equations. That wasn't too tricky. I had to remember what sum meant and what difference meant, but I've got it. My first variable look is already the same. So I don't even have any work to do. They're both x. So happy days. I can go straight to the taking away stage. So take, I'm circling that. And then I'm going to do what I can see. So x take x, x's are gone. I'm at positive y. So I've got 1y. And here it tells me to add another 1. So I'm going to have 2y equaling 53, take away 11. So that's going to be 42. Divide through by the 2. And my y is equal to 21. So x plus y is equal to 53, which means x plus 21 is equal to 53. Take off the 21 and x is equal to 32. So I'm saying that x is 32 and y is 21. Now, it makes sense to just not stop there. It actually makes sense to do the difference and see if I get 11. Because if I get 11, then I know everything has come out correctly and I wrote the simultaneous equations right and everything just works. So 32 take away 21 is indeed 11. So happy days. We've done the first one. Okay, so they can write you a fairly straightforward question. Okay, and the indicator that this is simultaneous equations is the fact that you've got 2 numbers that you don't know. That's going to give you 2 letters. 2 letters will straight away be taking you to simultaneous equations. Okay, so let's have a look at this one. Okay, we'll just move that back up a little bit so we can read it. Clean this off. Okay, so let's put that up on the screen. They could try and link it to shape. This does work as well. I think this one is, again, quite a straightforward one. If you just think about what you're looking at, think about what you're trying to write. So I would really love it if you would hit pause and just have a go. It might be that you just want to try and write the equations and then you want to check that you've done that right. And then maybe pause again to solve them. All right. So that you're not literally doing everything from start to finish. So get your equations first of all and then hit play. Okay, so opposite sides of rectangles. Yeah, so this side and this side are equal. That means that 2x plus y must equal 10, and that 3x minus 2y must equal 8. So if you got that, perfect. Now pause and keep going. If you didn't, hopefully that explains why you can now rewrite them, pause, and have a go at that method. Okay, I've got to get these the same. So we're timesing by 3 and by 2. That's going to give me 6x plus 3y equals 30. 6x minus 4y equals 16. So I'm going to show my takes and do that ringing. Really can make a difference. 6 takes 6, they've gone. I've got 3 and I'm having to add 4. That's going to give me 7y. 30 takes 16 is 14. I can see that the y is going to equal 2. Okay, now I've got y. I can just choose one of those equations. I'm going to choose 2x plus y equals 10. I know y is 2, so I've got 2x plus 2 equals 10. Take off the 2 and 2x equals 8. So x is equal to 4. All right. If you went on and got that, then absolutely brilliant. Well done. Okay. Quite a basic simultaneous equation, actually, once it was written. Okay, here is another one. Okay. Now, this one is a little bit wordier, which can make it feel a lot harder. And I've really got to find the equations from that information. And this is where it can be quite tricky. So what we're going to do is we're going to say, right, Bob's going to read it first of all and get a feel for the question. So Bob sold 75 tickets to a school fete. He sold entry-only tickets for £5 and tickets that included lunch for £8. So he sold 2 different types of tickets. So that's the first thing that I'm going to write down. He's going to have sold, I'm going to use my X and Y. Let's say X is the tickets for entry only, and Y are tickets that included lunch. So let's just say that. So what I've done is I've recognized that there's 2 different things, which means there's 2 different letters. I'm going to put those letters in place and I'm going to remind myself what they mean. And that's really important. Getting some labeling in helps you remember what you were trying to do in the first place. Okay. So he sold 75 tickets. So he sold entry tickets plus tickets that included lunch. He sold 75. So X plus Y is 75. Now we go back to working out what would be our second equation, because we need 2 if we're going to solve them. So he sold entry-only tickets for £5. So this is where I'm going to bring that in. Entry-only tickets for £5 means that for every X he sold, he got £5. So 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, and so on. So 5 times however many X's he sold, plus 8 times however many Y's he sold, will equal 444. So we'll put that with the other equation, and happy days, we've got exactly what we need. Now, they're not matching yet, so we need to do that as our first step. So I really need to multiply all of this by 5 so that I can obviously get the first terms the same. I've got to be careful because I'm running out of page here. So I'm going to have 5x plus 5y equaling 75 times 5. So that's 375. And I've obviously got my other equation to use as well. I'm not going to rewrite it. I'm actually going to put these, even though they're a bit smaller, underneath each other, because they're the 2 difference that I want to use. And quite nicely, this bigger one is above the smaller one. So it'll stop that going into negatives, which is quite nice as well. So I'm going to keep it in that order. I've obviously got a plus and a minus going on there. So when I do my takeaway, okay, I've got the x's have gone. 8 take 5 is 3y. 444 take away 375 is 69. And then when I divide through by the 3, I can see that y is going to equal 23. Okay, so now I've got x plus y equaling 75. X plus 23, I've worked out that y is 23, is 75. And then we're going to take away the 23 to leave us x equals 52. So to finish it off, we would write he sold 52 entry only tickets and he sold 23 tickets that included lunch. Okay, now it really does take a bit of practice to pull those equations together when the story can be a little bit complicated. So take your time and just do your best. That's all you can do. All right, hopefully the practice session that we're about to do will help. So here are the practice questions. I'm going to scroll through just slowly and then you can pause and work from the screen if you need to. Just consider the context of the story so that you can assign some letters. If your letters are different to mine, it's obviously that's not the important thing, just the final answer is. And also be patient and kind. If this is something that you've never done before, then it may take a little bit of a while to get used to getting those letters and those equations written. Just check as you go. Do a question, mark it. Do a question, mark it. So I'll just scroll through. I'll do the same with the answers and then I will see you next session.